Hello and welcome to another tutorial. We're going to continue our discussion on default platform toolchains. We saw macOS, which uses Apple Clang. We saw Linux Ubuntu, which uses GCC. And we saw Windows, which uses by default Microsoft Visual Compiler, which you should install it and then set up the path environment variables. And now let's, before jumping to the GraalVM native image, let's take a moment and discuss how we are going to set up our C++ development environment. And we've already saw that for a basically for a simple C++ application like one CPP file, you probably can just do it in a command line. But if you want to develop a large C++ application, then you have to use some sort of IDE or build system. And the idea is the same for Java, because both C++ and Java similar in the way that they are statically typed languages, and they have compilers that compile the source files. And we know that in the case of C++, the source file gets compiled to the native executable binary. In the case of Java, the source file gets compiled by the Java compiler or Java-C to an intermediate level called basically a bytecode or class files. Those are still binary files, but they're not the operating system doesn't understand them, but the JVM or Java Virtual Machine understands them. Now, obviously, we're not the focus of this course is not developing C++ applications. I will have a few lectures about native methods in Java, and then once we get to the GraalVM native. So the native methods in Java require using the Java native interface, right? And which means we are calling some C++ functions from Java. So you bind a Java method to a C++ function. In that case, you have to write the C++ code, the bridge that allows this communication between Java method and then C++. In that case, I will show you an example of how to write a C++ source file and then compile it to a dynamic library and then load it back in Java and then use the native method in Java. So first of all, we need to set up some sort of C++ development environment after getting familiar with the default toolchain of our platform, right? And we saw that the job, we use the platform's toolchain or the compiler to convert source files to executable binaries. And when we say source files, it means C++, and mainly the modern C++. That's my focus. C++ source files are, the convention is .cpp. Headers are .h or .hpp. My convention is to use .cpp for the source files and .h for the header files. It is recommended to use an IDE. It's highly recommended. Let's write it down. It's highly recommended to use an IDE. And then in the macOS IDE, you have a couple of options. Obviously, the default IDE that comes with macOS is Xcode. You just install the Xcode app and you can develop that. CodeBlock is open source. VS Code is open source. I believe even Microsoft Visual Studio has a Mac version, and I think the community edition is still free. So we're going to say MS Visual Studio. I believe there is a Mac version available. And then my favorite is Eclipse CDT, C development tool. And the reason is that I'm a big fan of Eclipse IDE. First of all, it runs on the JVM and it's platform independent. Now, obviously, CodeBlock and VS Code and all these IDEs, Xcode doesn't have a Windows version or a Linux version. CodeBlock, I believe it has a macOS and a Linux, a macOS and Windows version. I'm not sure if a Linux version is available. And MS Visual Studio, I don't think there is a Linux version available. But Eclipse CDT, it's based on Java, right? It runs on a JVM and therefore it's platform independent. Basically, Eclipse CDT is available for all platforms. Not only that, but the interface is exactly the same, right? Because the interface is designed in Java, so it's the same. That's why I'm a big fan of Eclipse CDT. You go ahead and download Eclipse IDE, and then you can directly download an Eclipse IDE version that already comes with the CDT plugin. If you just download the Eclipse IDE that has the Java development tool by default, then you can just separately install the CDT plugin from Eclipse Marketplace. And after that, once you install and restart Eclipse, you have in the perspective list, there is a new perspective for C++. And then once you switch to that, all the menus immediately switch to C++ development, right? And then you can create a C++ managed build project, which so Eclipse CDT by default you can select which kind of build system you want to use. Is it a CMake or make or just internal build system of the Eclipse, right? I usually use the make system build, which is which I'm familiar with. Recent versions of the Eclipse CDT also work with the CMake, right? So basically you go to Eclipse Marketplace and search for CDT, C Development Tool, and then you just install it, and after that you restart Eclipse and you're ready to go. So let's head to Eclipse here, and I'm gonna close all these files, and then help, we go to Eclipse Marketplace, and in the Marketplace basically let's wait a second for this to load, and then you can search for CDT. Obviously I've already installed it and the perspective is available, and so once this finishes loading, we can search for the CDT. Now there are some tabs here: search, recent, popular, favorites, and installed. If you're not sure if you've installed CDT before, so you can go to the install tab and then see if CDT is installed. I've already installed this, right? And then once you install and restart, you come here, this corner. This is the window that you add perspectives, right? I have Java perspective, C++ perspective, and even Python. So Eclipse IDE allows you to seamlessly jump between development. You can even install a plugin for developing Fortran, and so you can seamlessly jump between different perspectives. So this is your perspective menu, and I have the option to select C++, Java, or Python. If you install Fortran, for example, you have a perspective for right now. If you look at the for example, the file, new Java project, package, class, interface, enum. So these are related to the Java development. If I switch to C perspective, and by the way, each perspective you can also set it to have a different window configuration, which is very nice, right? If I jump back to my Java, you see the tabs are different. C++, the tabs are different. Python, it's different. So it's very nice that you can seamlessly jump between different developments. So if I jump to the C++ development and look at the files, new make file project with existing code, C++ project, convert a C++ auto tools project. So all the menus now are basically changed to C++ development, which is very nice, right? So what you do once you jump to the C++ perspective, right click, new C++ project. And you see we have different options. C managed build, obviously we want to create a C++. So C++ managed build using the CDT's managed build system. So this is the internal CDT's managed build. Now you can select a CMake project, so you have to have CMake installed, and then you configure it. Make file project, create a new project that builds with the make build tool using CDT's new core build system. This is like experimental. And then you can also select this one, Mission project. So I'm going to select the C++ managed build, and then what it's going to do on any platform, it basically automatically recognizes your toolchain. A toolchain is a set of tools, compiler, linker, assembler, intended to build your project. Additional tools like a debugger can be associated with toolchain. So Eclipse CDT usually automatically picks up on or detects the default toolchain of your operating system, which is very nice. And usually what I do, I create a executable project, hello world, just to quickly so test CDT, to quickly compile, make sure everything is fine. So I'm not going to add any author. I'm going to manage all my C++ files into a src directory. Next, and then you can select whether you want to compile in release and debug mode. Right now I'm just going to show a demo, so I'm not going to compile in debug. I'm just going to compile in release. And the difference here is that it just passes different flags to the default toolchain, to the C++ compiler, right? In release you get -03, which means the maximum level of optimization, and finish. And now it's going to create this test CDT project. And then it automatically picks up on your default toolchain and adds all the default include directories, right? In order to develop C++ applications, you have to add all the header files necessary, right? And we've seen these header files. These are in the, basically they come with the Xcode app, and then the Xcode tool, and then all the header files, and then also some command line tools, SDKs. And so these are different libraries. So basically, based on your default toolchain, Eclipse CDT figures out what are all the header files that are available for your development. Now, in macOS and Linux, there is an extra folder per user. It's called user local include. So if you've installed additional C++ libraries, for example, I've installed Boost, and then all the header files for the Boost are available. And then once you compile, you can also link to the binaries, static libraries, or dynamic libraries. So these are different libraries. For example, Boost, GSL, GNU Scientific Library, I've also installed it manually on my computer. So not only CDT picks up on the default toolchain, it also tries to pick up all the C++ libraries that you as a user have installed. And this user local include obviously only exists for macOS and Linux. On Windows, you kind of need to figure out what to do, and I'll show you how to do it maybe in the future lectures. But for now, I'm going to focus on just a quick demo based on macOS, right? So if your IDE doesn't pick up on the basically default toolchain, you can go to right click, go to the properties of your C++ project, and you have to manually configure this build. So right now it tells me that this build is the configuration is released. You can manage it, you can add a debug, and then build. The build type is external builder, and it's by default is using the make. And let's see if I have make installed on my computer. So let's open up a new. Obviously, in order to be able to do this, make should be available on your operating system, which means that the terminal should be able to find it. Which make? User bin make, so make -- version, and GNU make, right? And I believe once it comes with Xcode. If you don't have make installed, you have to install it. I believe it's an open source thing, and you can use it. You can basically switch to the internal builder. The difference is that with the make builder, it creates a make file, and then you can compile using the make, and Eclipse does that. Internal builder, it doesn't use the make file, so it doesn't create a make file that you can even use it on the terminal to compile. So for now, I'm going to stay with the external builder. Generate make files automatically, expand environment variable references make files. That's good. And it also shows the build directory. Right now my configuration is release, so it creates a directory called release and puts the binaries there in the release. All right. And then the behavior, and use a standard build arguments, right? And you can even do parallel building, multi-core, if you think you have a large project and you want to do, because the C++ compilers allow you to use multiple threads or multiple cores, right? Right now, we're just not going to use it. Use custom build arguments. These arguments will be passed to the make command line arguments. But right now, we're going to use the standard build arguments. Workbench build behavior, build on resource save. So basically the idea is that you have the workspace, and if you change something, for example, in the source code, do you want to automatically rebuild the project, or the default behavior is that you want to, so this is your build configuration, this hammer which is released, and this is, so when you click on this, it builds, and this is the configuration release. So this one is the configuration. So right now I'm compiling to an executable. I have a main. So let's select our C project, C++, and run the build manually. So as you can see, it runs a few terminal commands. The first one is make all. So what it does, it creates the make file. So let's look at the release. You see we have the make file, which just tells me include this makefile.init, and then remove all the files, and then include src.make, source.make, and these are all the directories that will be included. It says that just include the src in the make, right? Because this src directory has our source files. And then make CMD goals, and then CC dependencies, C++ dependencies, a lot of the options. So and then eventually the target is building this executable by including all these by executing all these goals, right? If you're not familiar with what make system is, you can just basically Google it and get familiar. So after you create this binary, right, this is our executable binary, right, in the release. It also, in the source directory, it also puts the object file O-O. These are the binaries, and D is the directories that were used to create this object file, right? So src test O came from compiling src test cdt.cpp, right? So it tells you which CPP files were compiled to generate this object file, right? It says that this object file test cdt.o came from compiling this C++. So it gives you extra information, and you can just select your source file and hit run, and it automatically let's write something here, hello world. When you do that, Eclipse automatically executes the binary that it compiled. So I changed something, so let's build again. It builds, and then let's run, and it works fine. So again, when you hit run on your source file, what happens? Eclipse actually executes this binary. So if I manually delete this binary and hit run, and it says binary not found, right? So basically, when you run the source file, I don't want you to get the wrong idea. What actually happens is that Eclipse executes the binary that has the name, right? But right now it says I cannot find a binary, so you have to build it again. And now you build it, and you get the binary, and then it can run it. So when you run a source file, it doesn't mean that Eclipse running the source file. It just means Eclipse runs the binary that is associated with the executable binary. Now, obviously, we can also open a terminal here and manually run the binary. I've shown you how to do it. You just, in the macOS and Linux, the current working directory, which is our release, does not, by default, it does not get appended to the path. You have to say dot and then test CDT, and it says hello world, right? So we can execute the binary just like any other native application in the terminal. Now, what we can do here is what I'm going to do, I'm going to delete this release, and then so let's see. So you can also look at the outline of your application. We're including iOS stream. We don't, the best practice is to not so use the open up the entire std namespace. Same with here, this one end line, and then you can build this, right? Build release. So you can now recompile again, and as you can see, Eclipse actually uses the G++-03, which means Eclipse just calling the G++ compiler, which is our default toolchain. And it also tells you that I found the GCC C++ compiler. The command is G++. And it also tells you which flags it's passing to the compiler to compile your CP file. -03 is maximum optimization. That's why we're compiling in the release mode. -W all means show all the warning. -C and then -F message length 0. -MMD and then which directories, and then we're compiling this test cdt.cpp. All right. Now the question is, what is the working directory when Eclipse launches the compiler? And as you can see, the relative directory is go one level up, and then src, and then test cdt.cpp. So basically what happens here is that when you run the build, Eclipse CDT changes the current working directory to the release directory, right? And then in order to get access to the CPP, you have to go one level up, and then you go into the root of the C++ project, and then go to the src, and then test CPP. Now we could actually, let's delete all these files, and then let's open a terminal here. open a terminal in the release directory. Now we can manually compile our application because it's a very simple one source file application, g++-o3-w all, and then go up, and we can use double quote, go up into the src, and then test cdt.cpp, and we can compile again, and then it puts it in the current working directory. So we get a.out. That's because we did not specify a particular name for the output, so we can also do that. So let's close this one. In order to give it a specific name for the output, you say -o, which means the output name, and then let's say test-_cdt, right? And we compile. Now it puts it in the current working directory, which is this, and then if I right click and hit run, let's see. Oh, so Eclipse always tries to use the make file. So when you try to build with Eclipse, basically it cleans up all the files that are currently in the release. And if you look at the make file, the first line is remove all the files that are in the current working directory, which is the release, right? So it cleans up everything, all the binaries that were already compiled, and then tries to redo. So let's clean this up. But right now we are directly compiling our application, so we're not using any make build system, right? So when you just type g++ and then compile the C++ code source file to an executable binary, you're not using a build system. You're just directly invoking the compiler. Obviously this only works for very small applications, but if the application gets large, then you have to use some sort of build system, otherwise it easily goes out of control. All right, so what we're going to do, I'm going to delete this release and then hit the build on our project, and now Eclipse creates all the make files and then executes the make, right? Again, to refresh your memory, there are two steps towards compiling a C++ source code to the native executable. One is compiling the CPP files, source files, to object files, which are the binaries, and each CPP gets compiled to a separate binary, and then linker puts or connects all these object files together and creates one executable binary, right? There are two stages, and the command both for compiling and linking is the same. It's just g++. So based on the flags that you pass, g++ decides whether you're compiling or linking, right? If you just say g++, it tries to do the compilation first and then linking. But if you just say -c, so -c is the flags that tells the g++, hey, I just want to compile, don't do the linking. And I can show you by again cleaning this. So let me write this here. So g++ by default first runs compilation and then runs linking. If you just want to compile, create the object files, which are the binaries, you have to pass the -c. So a flag -c tells g++ only compile, don't link, right? So so if I open a terminal again here, so previously we used this command to directly compile to an executable, but now what we're going to say is that we're going to say g++ -o3-w all -c, right? And then -o, the output is going to be .o, for example. And if you look at the release mode, there is no release folder, there is no executable file. It's just a binary file, object file. So if you open this up, it's just binary, right? And then if you want to convert this binary to an executable, you have to invoke the linker again, right? g++ and then test cdt.o -o test my app, for example. And now if you have multiple object files, you list all of them here, and then the linker tries to combine them together into one single binary. And if I say my app it's going to execute fine. Again, I'm telling you this stuff. These are not directly relevant to Java development or compiling a Java application to native executable binary, but it's very helpful for you to understand what's going on when you're compiling some source file to native executable binary, right? So back to the PowerPoint. So we can you can quickly install this C++ CDT development environment, and then it takes care of the make files and everything. You just add source files and then compile. Everything is very automatic, very nice. And then the next step is terminal, and I've already been using terminal quite some time in these lectures. And terminal, just a brief introduction or quick overview. Terminal is also known as command line, console, shell, bash, which is born again shell, etc. Right? In Windows, they call it command line or console. In macOS, Linux, we call it shell. And terminal is the bridge between the human and the operating system. And it's a purely text-based application, which means unlike a graphical interface, the terminal doesn't have any button that you can click. You basically end up typing a lot of stuff. Just like any other executable binary, it's a text-based application, and the way it works is, let's close this. There are executable binary applications. If you want to tell operating system or terminal to do something, you type a name, which then the operating system or the terminal interprets it as a application, an executable binary. For example, ls is a application executable binary, and lists basically the directories and the files, everything. If you type something that the terminal cannot find, it gives you an error saying that I cannot find it. Obviously, I'm using a interactive shell, which already highlights it in red, which means terminal couldn't find this command. If I say which, blue means the terminal is able to locate this application, or for example, make, right? It's blue. If I say make to or makes, it means it cannot find it because it becomes red. And again, this is because I installed this fish friendly interactive shell on top of my regular macOS terminal. All right. And terminal has buffers or streams, which are either input streams or output streams or error streams. And usually, if you want to save the outputs, for example, if you run an application, let's run this one more time. So what happens here is that when you type, for example, ls, this is executable, and the feedback that the terminal gives you is a text-based feedback, right? Obviously, this interactive shell has some highlighting, etc., but it has a buffer or a character buffer that shows to the terminal. Now, sometimes what you want to do, you want to save these whenever you have characters or strings, you can save them to a file. So you can say ls on this directory, and then hyphen basic, you can tell it or direct the output of this application, which is a string, to a file or something like these arrows means this arrow means grab the output of this application, which is a string, and redirect it to a file, for example, a text file or anything, right? And if you want to filter some of them, there is a pipe operator. Instead of arrow, you have pipe. Pipe means when you use arrow, you are directing to a file, right? When you use the pipe, you are redirecting the output of this to another binary application. For example, grep. Grep is for filtering something, right? Let's say any application that any of the outputs, everything that starts with MO, for example, and it says movie, and this interactive shell also tells me MO is red, which means this was fine. So the pipe means redirect the output to the other application. So if you have an application, you execute it, and now you want to redirect the text output of this application to another application, you use the pipe operator. If you use the arrow operator, let's see if this works. No, because arrow means redirect the output to a file, not another application. Remember, grep is also an application, so you're redirecting the output to a file, no such file or directory, right? With the arrows, you can redirect the file. So if you want to read the context of a file and then take them as the input to an application. You can basically use the input stream of the application. Right now the arrow, if you type the name of an application and then the arrow, it means you're using the output buffer of the application or the terminal, right? So I want you to understand this. Again, these concepts mainly apply to macOS and Linux. So Unix-based operating systems interaction with the terminal is very important. Advanced users prefer working with terminal. The main reason is that terminal provides a scripting. So you can create a script that runs hundreds of commands using terminal, right? So you just run the script and it does a lot of things behind the scenes. It runs lots and lots of commands, which is very nice because now it gives you a way of automating a lot of routine tasks, a lot of commands. Fish is an application that runs in terminal and adds some enhancements. It's available both for macOS and Linux. I highly recommend you install it and use it. It has a lot of highlighting features, and even in my bash RC I've set it to set by default. Anytime I run a new terminal, it immediately runs fish, so that I'm always in the fish shell instead of the original shell. If I want to exit the fish, I type exit and I go back to the macOS terminal, which is a little bit boring. It doesn't have any highlighting, etc. So I recommend you use the fish application, right? So I hope you really enjoyed this lecture. Please stay tuned and I'll see you in the next one.